Hello everyone. Here we are going to see Block 3, Unit 12. That is processing N jobs on M machines. So, structure of this unit is the objectives, introduction, example, procedure for determining the optimal sequence for N jobs on M machines, solved examples, sum up keywords, and some terminal questions. So, objective of this unit is in this unit, students are able to understand how to solve, maximize the efficiency and the free flow of the production at a minimum cost and minimum time. Let's see the introduction of this unit. Let there be n jobs, each of which is to be processed through m machines. Say m1, m2, and so on up to mn in the order m1, m2, m3, m. Let Tij be the time taken by the ith machine to complete the jth job. Next one is example. So consider a company which produces a number of items. Consider a company and that company produces a number of items. Each item must be processed by one or more of several machines. Okay. They have produced number of items, and each items must be processed on one or more machines. One or more machines. Certain machines processes many require that an item be processed on one machine prior to another. Therefore, a fixed sequence of machines may be necessary. That is, an item must be cleaned before it can be painted. For other process, however, it may be possible to deviate from a fixed sequence. This is what n jobs on m machines. Example for n jobs m machines. Okay. Next one is procedure for determining the optimal sequence of n jobs on n machines. So the iterative procedure of obtaining optimal sequence is as follows. The first step is to find minimum of T1G. Minimum of T1G. We have to find the minimum value for the first machine. Minimum value for the first machine. And next, we have to find the minimum value for the mth machine. The mth machine. The third thing is the minimum value for the second machine, third machine, fourth machine, and so on up to m minus 1 machine. The maximum value for from second machine to m minus 1 machine. So, what's in it is first machine, we have to find the minimum value for the first machine and the last machine, and we have to find the maximum value for in between the machines. That is second from second machine to m minus 1 machine. So here m machines are there. Keep that in your mind. M machines are okay. Then check whether that this two conditions are satisfied or first condition is minimum of T1J. Minimum of the first machine is greater than or equal to maximum of the second machine or the m minus 1 machine. Okay. Suppose in your problem, if three machines are there, so we have to check the minimum of the first machine is greater than or equal to maximum of the second machine. Or minimum of the third machine is greater than or equal to maximum of the second machine. This is what the conditions. So, if any of these conditions are satisfied, Moving on to the next step. Yes, step 3. If the inequalities in step 2 are not satisfied, means method fails. Otherwise, we will jump on to the next step. So step 4, convert if these two conditions, any one of these two conditions are satisfied, then convert the M machine problem into two machine problem by introducing two fictitious machines G and H, that is dummy machines D and H, such that the machine G is calculated by using the formula. We have to add the first two machines or first M minus 1 machines, and H is replaced by the formula. From we have to add the second machine up to the M machine. Second machine up to the M machine. After that, we have to determine the optimal sequence of N jobs through two machines by using optimal sequence algorithm or Johnson's algorithm. So next step is, in addition to that, if Tij is equal to T2 plus T3 plus and so on up to Tm is a fixed positive constant, then we have to determine the optimal sequence of N jobs and two machines, that is M1 and MM, in the order M1 MM by using the optimal sequence algorithm. Okay. So next thing is moving on to the worked problems. In the first example, find an optimal sequence for the following sequencing problem of 4 jobs and 5 machines when pausing is not allowed, of which processing time in hours is given below. So they have given the job values as A, B, C, D, and E, and they have given the 4 machines. They have given 4 machine problem. First of all, we are going to check two conditions. Any one of the two conditions are satisfied or not. For that, we have to find minimum of the first machine. Minimum of the first machine, that is 6. That is 6. Minimum of the second machine B, that is also 6, and maximum of B, C, D. Maximum of B is 6 and maximum of C is 5 and maximum of D is 6. Then we have to find the minimum value for the last machine E. It is also 6. It is also 6. Since minimum E is equal to maximum of Bi comma D, maximum of the machine D and B, and minimum of A is equal to maximum of C. Therefore, this conditions are satisfied. Hence, this 4 machine problem can be converted into 4 jobs and 2 fictitious machines G and H. 2 fictitious machines G and H. So, G is calculated by using the formula A plus B plus C plus D, which means we have to add the job values for the machines A, B, C, D, processing time values. Okay, then H is calculated by adding the processing time values for the machines B, C, D, and E. So, for the first for the first job 1, G is replaced by 7 plus 6 plus 5. 7 plus 5 plus 2 plus 3. It is 17. And for second job, G is 21. For the job 3, G value is 20. For job 4, G value is 16. Whereas for job 1, value of H is 19. For job 2, value of H is 25. For the third job, value of the H is 23. And for job 4, value of H is 14. So, given 5 machine problem can be converted into 2 machine problem. Hereafter, we are going to find the optimal sequence. The optimal sequence. Okay. The above optimal sequence will be 1, 3, 2, and 4. As you all know that how to find optimal sequence. It is 1, 3, 2, and 4. Okay. Then total elapsed time corresponding to optimal sequence can be obtained by using the below table. In this table, the first column denotes the job values. That job values, we have to write this job values by the optimal sequence order. That is 1, 3, 2, 4. 1, 3, 2, 4. Then machine A in out value, machine B in out value, machine C in out value, machine D in out value, machine E in out value. Okay. For machine A, the first in value is always be 0. For machine A, the first in value is always be 0. And the out value will be the addition of in value 0 plus the processing time for job 1 in machine A. It is there in the problem. Job 1 for machine A. It is 7. So, we have to add 0 plus 7. It is 7. So, write the 7 here, and for out value, we have to add in value 7 plus processing time for third job in machine A. It is 5. So 7 plus 5, 12. So write this 12 here, and for out value, we have to add in value 12 plus processing time for the second job in machine A. It is 6. So 12 plus 6 is 18. So 18 here, and for out value, addition of the in value plus the processing time for job 4 in machine A. So we will get 26. 26. Okay. So for machine B, the first in value is the first out value of machine A. It is 7. 7. out value of machine B is calculated by adding the in value 7 plus the processing time for the job 1 in machine B. Job 1 in machine B. It is 5. So 7 plus 5. 7 plus 5. It is 12. Then write this 12 here. Before that, we have to check or compare the maximum of this 12 and 12. Both are equal, right? So we have to write 12 here. And for the out value, how to find the out value? Addition of in value 12 plus the processing time for job 3 in machine B. It is there in the problem. It is 4, I think so. So 12 plus 4 is 16. Then we have to compare these two values, 18 and 16. Maximum of 18 and 16. It is 18. So write 18 here, and for out value, how to find the out value? Addition of in value 18 plus processing time for second job in machine B. It is 6. So 18 plus 6 is 24. Then compare these two numbers, 24 and 26. Maximum of 24 and 26. It is 26. So in value is 26, and for out value, addition of the in value 26 plus processing time value for job 4 in machine B. It is 3. So 26 plus 3 is 29. 29. Similarly, you have to find machine C, D, and E. Okay, so for machine C, the first in value is the first out value of machine B. It is 12. Then how to find the out value? Addition of in value 12 plus the processing time for the first job in machine C. It is 2. 12 plus 2, 14. So 12 plus 2, 14. Then we have to compare 14 and 16, and you should write only the maximum of 14 and 16 here. It is 16. Then out value is the addition of in value 16 plus the processing time for third job in machine C. It is 5. So 16 plus 5 is 21. And you should write here as the maximum of 24 and 21. Maximum of 24 and 21. It is 24. 24. Okay. Then out value be calculated by in value 24 plus the processing time for the second job in machine C. It is 4. So 24 plus 24, 24 plus 4 is 28. Then compare these two things. We should write maximum of 29 and 28. It is 29. Then out value is addition of in value 29 plus processing time for the fourth job in machine C. It is 3. So 29 plus 3 is 32. Okay. Similarly, we have to find the in out values for machine B. The first in value is the first out value of machine C 14, and out value is calculated by in value 14 plus processing time for the first job in machine D. It is 3. So 14 plus 3 is 17. Then we have to compare these two things, 17 and 21, and we should write maximum of 17 and 21 here. It is 21. 21 is the in value for job 3, and the out value for job 3 is calculated by in value 21 plus the processing time for the third job in machine D is 6. So 21 plus 6 is 27. Then 27 and 28 is there. We have to compare these two things, and for a second job, out value is maximum of 28 and 27. It is 28. Then for out value, we have to add in value 28 plus processing time for the second job in machine D. It is 5. So 28 plus 5 is 33. Then maximum of 33 and 32 is going to be right here. It is 33. So for out value, in value 33 plus the processing time for the fourth job in machine B. It is 2. So 33 plus 2 is 35. 35. Okay. Then machine E. Machine E's first in value is machine D's first out value 17. Then out value is calculated by adding in value 17 plus the processing time for the first job in machine E. We get 26. Then here we are going to write the maximum of 27 and 26. It is 27. Then out value is calculated by adding in value 27 plus a processing time for third job in machine E. It is 8, so 35. Then compare these two things, 35 and 33. Here we are going to write the maximum of 35 and 33. It is 35. It is 35. So out value is calculated by adding in value plus processing time for second machine in job E. It is 45. Then for job 4, in value is 45. its out value is calculated by adding the in value 45 plus the processing time for job 4 in machine 3 is 6. So 45 plus 6 is 51. 51. Then we have to find the minimum total elapsed time. So it is the lost machine's lost out value. Here the lost machine is machine 3 and its lost out value is 51. So the minimum total elapsed time is 51 hours. Then ideal time for machine A. It is calculated by using the formula total elapsed time minus ideal time for, lost out value of machine A. It is 26. So 51 minus 26. 51 minus 26. It is 25. Then ideal time for machine B is calculated by first in value in machine B, first in value 7 plus the difference between 12 and 12 is 0, the difference between 18 and 16 is 2, the difference between 26 and 24 is 2, and plus the difference between total elapsed time 51 minus final out value 29. It is 33 hours. 33 hours. Then ideal time for machine C. Ideal time for machine C. It is the first in value. The first in value for machine C is 12 and the difference between 16 and 14 is 2. The difference between 24 and 21 is 24 and 21, and the difference between 29 and 28, and the difference between the total elapsed time and the final out value 32. Okay, so it will give 37 hours. 37 hours. Then ideal time for machine D. Ideal time for machine D. It is calculated by the first in value 14 plus the difference between 21 and 17 plus the difference between 28 and 27 plus the difference between total elapsed time and the final out value 35. So it will give 35 hours. Then ideal time for machine E. Ideal time for machine E. It is the first in value 17 plus the difference between 27 and 26 plus the difference between 35 and 35 is 0. No need to write that thing. And the difference between 45 and 45 is again 0. Again, no need to write. And it will give 18. It will give 18 hours. 18 hours. Next example number 2, find solution of processing 5 jobs through 4 machine problem. They have given 4 machine problem. They have given 4 machine problem. Okay, so first of all we are going to check that conditions are satisfied or not. For that, for that, for that, we have to check the minimum of first machine. It is 9, and the maximum of last machine, it is 15. It is 15. Since any of these conditions, minimum of the first machine is greater than or equal to maximum of the last machine, and the minimum of the second machine or third machine is greater than or equal to maximum of the last machine. So here it is satisfied. So given four machine problem can be converted to two machine problem. Given four machine problem can be converted to two machine problem. And for machine, here they have given the processing time. The smallest processing time is 18 hours for job 2 on machine 2. So job 2 will be processed last. So job 2 will be processed last. Then the next smallest processing time is 19 hours for job 3 on machine 1. So job 3 will be processed first. Then the next smallest processing time is 19 hours for job 4 on machine 2. So job 4 will be processed before job 2. Then the next smallest processing time is 21 hours for job 1 on machine 1. So job 1 will be processed after job 3. And finally, the next smallest processing time is 21 hour for job 5 on machine 2. So job 5 will be processed before job 4. According to Johnson's algorithm, the optimal sequence is 31542. 31542. So next we are going to find the in-out values for all the machines. The in-out values for all the machines. So in the first column, we are going to write the job value as in the optimal sequence order 31542. After that, after that, you have to find the in-out values for all the machines. Machine 1, 2, 3, 4. Okay. Then Then after that, total elapsed time. It is the find lost machine for lost out value. It is 84. Lost machine for lost out value is 84. Then ideal time for machine 1. It is calculated by total elapsed time 84 minus lost out value of M1 866. It is 18. Then ideal time for machine 2 is calculated by first in value 9 plus the difference between 20 and 14 plus the difference between 37 and 24 plus the difference between 53 and 43 plus the difference between 66 and 55 plus the difference between total elapsed time 84 minus final out value lost out value of machine 2 69. You will get 64. Then ideal time for machine 3. How we can calculate? It is the first out value first in value 14 plus the difference between 24 and 19 plus the difference between 43 and 30 plus the difference between 55 and 47 plus the difference between 69 and 63 plus the difference between total elapsed time 84 minus lost out value of machine 3 76. So you will get 54. Then ideal time for machine 4. It is the first in value 19 plus the difference between 32 and 32 is 0, no need to write, and the difference between 47 and 47 is again 0, again no need to write, and the difference between 63 and 58 plus the difference between 76 and 72. You will get you will get 28. So here what we have concluded that in this unit students have learned about the optimal sequence for n jobs on m machines problem. So the characteristics of the optimal sequence for n jobs on m machines and make solve the problem the optimal sequence for n jobs on m machines. And they have given some keywords: ideal time and total elapsed time. Total elapsed time is nothing but the time between the time between starting the first job and completing the last one. And ideal time means ideal time on a machine is the time that the machine remains ideal during the total elapsed time. Okay, and they have given some terminal questions for you. You can make use of it. Thank you. We'll see in the next unit.